Hi, this video is about Avogadro's number and the mole. So we've learned a little bit about what a mole is, and we talked about Avogadro's number. We also learned about molar mass or formula weight, and we've learned how to use our units in dimensional analysis to solve problems. This video is going to put all that together, and you'll see it's not very hard. Avogadro's number, and the abbreviation is a capital N and then a subscript capital A. It's a really big number that you don't have to have memorized, but you probably will because you'll use it a lot. But it's 6.022 times 10 to the 23rd. So if you have that number of anything, then you've got a mole of it. All right, now we can convert atoms or molecules, things in chemistry that are really, really small, to moles. And Avogadro's number is the conversion factor. And Avogadro's number is the same thing as saying 1 mole. And so let's go ahead and practice. We've got 0.45 moles of hydrogen gas. So just like we learned when we did dimensional analysis, what we need to do is you always start with the number that's given in the problem and the unit. So 0.45 moles, and we don't want moles, so we're going to put that unit in the denominator, and we want hydrogen, and hydrogen's diatomic, so it's H2, and so it's a molecule. If it had just been like an H, it would be an atom, but this is a molecule. And now we need that conversion factor. The unit we want is on the top. We can cancel mole. And 1 mole is Avogadro's number. And because Avogadro's number is in the numerator here, we are going to multiply 0.45 times 6.022 E23. And so I want you to do this on your calculator. So if you don't have your calculator, stop the video and get one, and make sure that you're using your calculator properly. And what we get for this, and to be expected, I mean, this isn't a mole, it's about a half a mole. So we're going to get something smaller than 6.022 times 10 to the 23rd. And we get 2.7 times 10 to the 23rd, and that is hydrogen molecules. So not hard at all. If you have moles and you want atoms or molecules, you just multiply by Avogadro's number. Okay, now the other thing we can do is go backwards. You can start with molecules or you could start with atoms, and then you can go to moles. So here we go. Again, start with what's given, and it's 3.075 times 10 to the 25th. Don't forget your unit, and that's molecules of oxygen. Again, oxygen is our diatomic, O2. And we're going to put molecules down here. So we're going to put molecules of O2. And what do we want? We want moles. It asks for calculate the number of moles. And 1 mole is Avogadro's number of molecules. So Avogadro's number goes with molecules. The 1 goes with a mole. In this problem, you're going to take the 3.075 e to the 25th, and you're going to divide, because this is in the denominator, by Avogadro's number, and your answer is going to be 51.06 moles. Now, if you look at what you're starting with, that number is bigger than 10 to the 23rd. So we're going to expect it to be much greater than 1 mole, and it is 51.06 moles of oxygen molecules. Okay, so that's how you convert between atoms or molecules and moles, and you use Avogadro's number. All right, now, this molar mass that we've been talking about, a mole, say, of any element on the periodic table, and so I just happened to pick copper. The mass of 1 mole of copper atoms is 63.55 grams. That unit is grams. So that is called molar mass. What we were calling formula weight can be the same numerically, but if we give it the unit grams, then we have to say grams divided by 1 mole. That's how many grams are in a mole. And so we're going to start using molar mass when we calculate these, and the unit is grams per mole. And so the molar mass of sulfur would be, look at your periodic table, and that number right under the symbol is 32.07. And so the molar mass of sulfur is 32.07 grams per mole. Sodium hydroxide, NaOH. So we have one sodium, it's 23, one oxygen, which is 16, and one hydrogen. And when we add them all together, we get the molar mass of sodium hydroxide is 40 grams per 1 mole. All right, now how do we use molar mass? Well, molar mass, see, the unit is grams per mole. It's used as a conversion factor between grams to moles. All right, so again, let's go ahead and practice this. How many moles of helium atoms? So we have 6.46 grams of helium. Always start with what's given. 6.46 grams of helium. We don't want grams of helium, so that immediately, whatever that unit is, put down here. We want, what's the question asking for? How many moles? So we're going to put moles up here. We're going to go to helium on the periodic table, and right under the symbol, you will see this number there, 4.00. That's how many grams are in 1 mole. So what we're going to do is we're going to take 6.46 and divide by 4, and we're going to get 1.62 moles of helium. You look on the periodic table, and 1 mole has a mass of 4 grams. We have 6.46 grams. It's going to be a little more than 1.5 moles, and we find that it is. Okay, so notice what happened. We had grams. We divided by the molar mass to get moles. Now, here's the opposite. We have, we are starting with moles. So we've got 0.356 moles of zinc. So this time we started with moles, and we're going to put moles in the denominator. Whatever unit's there, immediately put down here. 1 mole of zinc has a mass of 65.38. I got this number right under the symbol for zinc on the periodic table. And the answer is 23.3 grams. So what did I do here? I had moles of zinc, so I multiplied by the molar mass of zinc, and I got grams of zinc. So 0.356 times 65.3. Okay, now we're not going to do anything new, except instead of using just a single element, we're going to use here, we've got sulfur dioxide. So sulfur dioxide, SO2. All right, let's start with what's given, 6.07 grams of SO2. And they want moles. So grams of SO2 go down here. Moles goes in the numerator. 1 mole. We're going to have to get the molar mass of SO2. So we'll go to our periodic table, and sulfur is 32.07. And oxygen is 16 times 2, because we have 2 of them. And when we add that all together, our sulfur dioxide has a molar mass of 64.07 grams per 1 mole. Keep that number, 64.07, where the grams is, 64.07. So what do? We take the number that was given, 6.07 grams, divide by 64.07, and we get 0.0947 moles of sulfur dioxide. Again, we had grams, we divided by the molar mass. And last but not least, here we have calcium hydroxide. And so here's what we want to do. Start with what's given. See, the process is the same for all of these. Moles of calcium, calcium's +2. Hydroxide is -1. We don't want moles of calcium hydroxide. We put that in the denominator in our equivalence box. And 1 mole of calcium hydroxide, well, let's figure it out. The molar mass of calcium is 40.08. We have 2 oxygens. That 2 distributes through. So we got 2 times 16. Whoops, excuse me. I don't know what happened there. And we've got 2 hydrogens. That's 2 times 1.01. The molar mass of our calcium hydroxide is 74.10 grams per mole. And so that 74.1 grams goes in our numerator. because the question is asking us for how many grams, so we want that in our numerator. So here we've got moles, 0.250 times 74.1. If you got moles, you're going to multiply by the molar mass to get grams. And our final answer is 18.5 grams. Okay, so if you have got atoms or molecules and you want moles, or if you've got moles and you want molecules or atoms, use Avogadro's number. If you got grams and want moles, or moles and you want grams, you use the molar mass. So here's a little mini conversion map. That's just what I had just said. Atoms or molecules, use Avogadro's number to go back and forth. Whenever you have moles that you start with, you multiply by Avogadro's number. Down here, if you start with moles, you multiply by molar mass. If you have grams, you divide by molar mass to get back to moles. We're going to practice this. It's pretty important, and luckily, it's pretty easy.